The cutting-edge technology of Europe's biggest greenhouse. The largest greenhouse in Europe is a state-of-the-art establishment that represents the direction of sustainable agriculture. Covering an area the size of 80 soccer fields, it uses state-of-the-art techniques and cutting-edge technologies to generate some 300 million plants a year. In addition to satisfying the expanding needs of the European market, this cutting-edge greenhouse places a high priority on ecological balance, energy efficiency, and environmental sustainability. In this video, we will go through 7 key points highlighting its advanced features and contributions to modern horticulture. Number 7. Massive scale. The largest greenhouse in Europe, covering an area equivalent to 80 soccer fields, is a remarkable achievement of contemporary agricultural engineering. Built to produce 300 million plants a year, this large facility offers a wide variety of flowers, herbs, and vegetables that are specifically suited to the intricate and changing needs of the European market. Because of the sheer size of operations, several plant kinds can be grown at the same time, allowing the greenhouse to react quickly to seasonal trends and customer preferences. For instance, the greenhouse can effectively increase production during times of high demand, such as spring for flowers and summer for crops. This enormous capacity not only increases output, but also makes large economies of scale possible, which lowers costs per unit while preserving product quality and uniformity. Furthermore, the size presents special chances for research and development projects. The facility's big space allows it to carry out extensive tests on novel plant species and cutting-edge growing methods. Through these trials, the greenhouse may quickly identify innovative ideas that work, and then adopt modifications that improve quality, yield, and sustainability throughout the greenhouse's operations. This never-ending cycle of innovation helps the greenhouse maintain its top spot in the horticultural sector. Number 6. Sustainable energy use. The greenhouse's advanced energy management systems serve as an excellent example of its strong dedication to sustainability. Essentially, it is a combined heat and power system that effectively produces heat and electricity from natural gas. Compared to conventional systems that function independently for heating and electricity generation, this dual-purpose technology dramatically reduces energy waste by capturing waste heat produced during the production of power and using it to warm the greenhouse environment. This reduces overall energy expenses while simultaneously improving operational efficiency. The building also has a large array of solar panels that capture solar radiation and convert it into renewable energy. This reduces the facility's dependency on non-renewable energy sources and the carbon emissions that come with energy use. By utilizing the Earth's natural thermal energy, geothermal heating is included into the facility to ensure ideal plant growth temperatures without using excessive amounts of electricity. This further improves sustainability. When these efforts are combined, the carbon footprint connected with agricultural production is minimized, which contributes to global sustainability goals and a dramatic reduction in operating expenses. The greenhouse provides as an example of how large-scale farming businesses can switch to more environmentally friendly methods without sacrificing output. Number 5. Advanced irrigation techniques. Effective water management is essential for greenhouse operations to be successful, and this facility shines because of its creative rainwater harvesting system. The greenhouse ensures that plants receive nutrient-rich rainwater free from chemical treatments while conserving valuable freshwater resources by collecting rainwater from its broad roofs and storing it in big basins. After being gathered, the water is carefully fed through a sophisticated irrigation system that uses subsurface or drip irrigation to precisely distribute the water to the plant roots. These techniques are especially good at reducing runoff and evaporation losses while increasing water efficiency, making sure that every drop matters in maintaining plant health. In addition, the system makes use of advanced soil moisture sensors that track moisture levels continually in real time. By using these sensors, automated modifications can be made based on the actual demands of the plants as opposed to depending on set timetables that might not accurately reflect the current situation. In addition to maximizing water use, this degree of accuracy encourages healthier plant growth by avoiding overwatering or underwatering, two frequent mistakes made in conventional irrigation techniques that can result in disease or stunted growth. As a result, there is much less water waste and a very effective water management system that promotes plant health and environmental sustainability. Number 4. Automation and robotics. The greenhouse's combination of robotics and automation marks a revolutionary advance in labor management and agricultural productivity. In order to maximize yield potential, advanced robotic systems can perform a variety of tasks at speeds and precision levels that are not possible for human laborers. For example, these robots can plant up to 15,000 cuttings per hour with remarkable accuracy, ensuring that each plant is spaced and positioned optimally. In an industry where profit margins can be slim owing to rising labor costs and competition, automation greatly lowers labor costs by streamlining labor-intensive tasks like planting, watering, and harvesting. Apart from planting, robotics is used to keep an eye on the health of plants by using advanced image recognition technology to identify early indicators of illness or nutrient deficiencies. This enables prompt interventions that can reduce crop loss and increase overall output. Furthermore, automated systems maintain ideal growing conditions continuously without the need for constant human supervision by modifying environmental settings in response to real-time data gathered from sensors positioned throughout the greenhouse. Automated inventory management systems also keep a close eye on stock levels and forecast requirements using present production rates. This capacity minimizes waste by ensuring that supplies are ordered only when needed, maximizing operational efficiency and enabling effective resource allocation. Number 3. Ecological pest management. This greenhouse uses ecological methods that prioritize biodiversity and natural balance within its ecosystem to manage pests in an innovative way amidst the growing scrutiny of chemical pesticides and their potential harm to human health and the environment. In addition to being introduced into the environment for natural pollination, beneficial insects like bumblebees are also part of a larger plan to increase biodiversity within the greenhouse ecosystem itself. Flower output increases without the need for artificial means or the increased labor costs associated with manual pollination techniques by enhancing the natural pollination processes that are supported by these insects. Furthermore, ladybugs are deliberately employed as an organic means of managing pest populations. These scavenger insects efficiently control aphid populations without endangering beneficial species or upsetting the natural equilibrium in the greenhouse. By establishing a self-sustaining ecosystem where natural predators control pest populations and reduce the need for chemical pesticides, this all-encompassing strategy promotes biodiversity and leads to healthier crops that are more resistant to pests and diseases and positively impact environmental sustainability. Number 2. Climate control innovations. In a greenhouse, maintaining ideal growing conditions is critical to optimizing plant health and productivity, particularly in light of the year-round variations in external weather. Modern climate control technologies are integrated into this facility to create perfect microclimates that are particularly suited to fulfill the needs of different plant species at different growth phases. By using intelligent shading systems, it is possible to automate adjustments based on the amount of sunlight present at different times of the day. This guarantees that plants receive enough light without becoming overheated during the strongest part of the day, which is essential for avoiding stress-related problems that could negatively impact growth or yield quality. Moreover, during gloomier days or seasons, energy-efficient LED lighting enhances photosynthesis, while using a lot less energy than conventional lighting techniques like high-pressure sodium lamps, which eventually results in cheaper operating expenses. High-tech sensors continuously measure the humidity and temperature inside the greenhouse. Based on changes in the outside weather or the needs of the plants inside, these sensors can adjust the heating or cooling system in real time, ensuring that the best growing conditions are maintained all year round. Number 1. Location efficiency. As one of Europe's logistical hubs, Germany is known for its robust infrastructure network, which includes highways, railways, and ports that are ideal for efficient distribution across European markets. The greenhouse's strategic location, which is close to major transport routes, plays a crucial role in both its operational success and sustainability efforts. Because of this close proximity, products can be delivered to retailers and wholesalers quickly. Fresh products reach market destinations, which is important for customer satisfaction and sales success in today's fast-paced marketplace where perishable goods like flowers and vegetables must remain fresh. Moreover, the greenhouse's proximity to waste incinerators allows it to use the excess heat produced by these establishments as part of its heating system. This creative integration not only improves energy efficiency, but also makes a substantial contribution to waste reduction efforts by turning heat energy that would otherwise be discarded into a valuable resource that is necessary to sustain ideal growing conditions inside the greenhouse environment all year round. Overall, by reducing transportation emissions related to product distribution and encouraging local resource utilization, this strategic placement maximizes operational efficiency and supports larger sustainability goals, ultimately making a positive contribution to the adoption of sustainable agricultural practices. These in-depth analyses show how the biggest greenhouse in Europe revolutionizes contemporary agriculture, while skillfully meeting environmental concerns and market demands throughout the continent by fusing innovative technologies with sustainable practices. Thanks for watching our video, and don't forget to subscribe.